Welcome to i4Math, your ultimate destination for CBSE Class 12 Maths Board Exam preparation. Here you will find clear explanations, shortcut tricks and step-by-step solutions to help you excel in the subject and score full marks. Don't forget to subscribe for more lessons like this video, comment your doubts and share with your friends. Let L be the set of all lines in XY plane and R be the relation in L, defined as R which is equal set of all order pairs L1, L2 such that L1 is parallel to L2. Show that R is an equivalence relation. Find the set of all lines related to the line y is equal to 2x plus 4. Subscribe to i4Math and WhatsApp 877-839-3314. I'm taking online class. If you want, you contact me through this WhatsApp number. Now let's see the solution. Reflexive relation. Let L1 is a line which is taken in the set of line L. L is parallel to L1. See, any line is parallel to that line. So L1 is a line which is parallel to itself. So L1 is parallel to L1. So what will happen? The order pair L1, L1 which will be an element of R. So R is reflexive. And then symmetry. Let L1, L2 taken from the set L. Take the order pair L1, L2 in R. So the order pair L1, L2 in R means what? L1 is parallel to L2. If L1 is parallel to L2, can we conclude as L2 is parallel to L1? Yes, of course. L2 is parallel to L1. So L2 is parallel to L1 means the order pair L2, L1 will be in the relation R. So R is symmetric. Next, transitive. Let L1, L2, L3. I'm taking three lines in the set L because the set L contains all lines. Take L1, L2 and L2, L3. These two order pairs I'm taking from the relation R. L1, L2 in R means what? L1 is parallel to L2. And L2, L3 in R means what? L2 is parallel to L3. So L1 is parallel to L2 and L2 is parallel to L3. Can we conclude as L1 is parallel to L3? Yes, L1 is parallel to L3. So L1, L3, the order pair L1, L3 belongs to R. So R is transitive. See, R is reflexive, R is symmetric and R is transitive. So hence R is equivalence. Next, find the set of all lines related to the line y equal to 2x plus 4. See, the set of all lines which are related to the line y equal to 2x plus 4 are parallel lines. So the set of all lines which are parallel to y equal to 2x plus 4 are y equal to 2x plus c. So the set of all lines which are related to y equal to 2x plus 4 is y equal to 2x plus c. C can take any values. You see this question, let A which is equal to R minus 3 and B which is equal R minus 1. Let F is defined from the set A to B. F of x which is equal to x minus 2 divided by x minus 3 for all values of x in A. Show that F is 1 to 1 and onto. See, what is the condition for 1 to 1? See, if you take f of x1 which is equal to f of x2 and if you are able to prove x1 equal to x2, then f is 1 to 1. So let f of x1 equal to f of x2. Substitute x is equal to x1 in f of x. So x1 minus 2 divided by x1 minus 3 will come. Similarly, substitute x is equal to x2. So what we will get? x2 minus 2 divided by x2 minus 3. Now let's do the cross multiplication. x1 minus 2 into x2 minus 3 which is equal to x2 minus 2 into x1 minus 3. Now apply the distribution law, multiply x1 into x2, x1 into x2 minus x1 into 3, that is 3x1 and then minus 2 into x2 and then minus into minus is plus 2 3s are 6. Next, x2 into x1, x1 into x2 and then x2 into minus 3, minus 3x2 and then minus 2 into x1, minus 2x1 and then minus 2 into minus 3, that is plus 6. Now cancel x1, x2 on both the sides, similarly 6 on both the sides. So bring this minus 2x1 to the left hand side. So plus 2x1 and then minus 3x1 already is there in the left hand side. Similarly, minus 3x2 is there in the right hand side. Take this minus 2x2 to the right hand side. So 2x1 minus 3x1 is minus x1 minus 3x2 plus 2x2 is minus x2. So cancel minus on both sides, x1 equal to x2. So how we started f of x1 equal to f of x2. Now we finish at x1 which is equal to x2. So f is 1 to 1. Now let us prove the onto. So what is given in the question? F of x equal to x minus 2 divided by x minus 3. But what is the meaning of f of x? That is y. So y equal to x minus 2 by x minus 3. Now do the cross multiplication. Y into x minus 3 which is equal to x minus 2 into 1. So x into y, xy minus 3 into y minus 3y which is equal to x minus 2. Now let's find the value of x. So collect all the x values to the left hand side and the rest of the x value take it to the right hand side. So xy minus x, take this x to the left hand side. So xy minus x which is equal to, take this minus 3y to the right hand side. So 3y minus 2. So take the x outside from xy minus x. So x into y minus 1 will come which is equal to 3y minus 2. Now let's find the value of x. Take this y minus 1 to the right hand side. So 3y minus 2 divided by y minus 1. So we calculated x equal to 3y minus 2 divided by y minus 1. This x is not defined when y is equal to 1. Because when y equal to 1, what will happen? 1 divided by 0 will come. Anything divided by 0 is not defined. So clearly x is not defined and y is equal to 1. Let's take the f of x which is equal to x minus 2 divided by x minus 3. Here substitute x is equal to 3y minus 2 divided by y minus 1. So f of 3y minus 2 divided by y minus 1 which is equal to x minus 2. But what is x value? 3y minus 2 divided by y minus 1. And then minus 2 divided by x minus 3. What is x value? 3y minus 2 divided by y minus 1. And then minus 3. Now let's take the LCM. 3y minus 2 into minus 2 into y. Minus 2y and minus 2 into minus 1 plus 2. Whole divided by 3y minus 2 into minus 3 into y minus 3y. Minus 3 into minus 1 is plus 3. In numerator and denominator, y minus 1 are there. Actually, the y minus 1 is dividing both numerator and denominator. So we can cancel this y minus 1. So directly we can write 3y minus 2 minus 2y plus 2 divided by 3y minus 2 minus 3y plus 3 by cancelling y minus 1 from numerator as well as the denominator. In the denominator, 3y minus 3y is there. So 3y minus 3, what is the value? 0. And the minus 2 plus 3, the value is 1. So denominator value is completely 1. What about the numerator? 3y minus 2y, that is 1y. And then minus 2 plus 2, 0. So 1y plus 0 is y divided by 1. That is y divided by 1. So y divided by 1 is y. So f of x is equal to y. Thus, for each y in the codomain B, that is B is equal to r minus 1, there exists x in A. What is A here? Domain. A value is r minus 3. That is, thus for each y in B, there exists x in A such that f of x is equal to y. So what it means? F is onto.